Welcome to today's lesson. Today we're going to practice on how to graph piecewise functions. So let's do a bunch of examples in order for me to show you a generic strategy that will help you put these pieces together. So let's begin by looking at this example. So now to begin with, we're going to have to pay attention to the domain because the domain is going to tell us where the graph is going to exist here. So the first thing that comes to my attention is this 4 right here. So I have to pay attention to this 4 because this is where the jump is going to occur if a jump exists. So let's begin by searching for the 4 here. So I'm going to look at my x-axis and I'm going to look for 4. It's right there. So I'm going to draw a little dotted line here, indicating that this is where a potential jump is going to happen, if it happens. So now let's begin by graphing this part of the piecewise function, 1/2 x minus 3. So I'm going to graph this by making use of the y-intercept here. So notice that the y-intercept is -3. So I can go ahead on the y-axis, plot that point. It's going to be right here. So I'm going to plot it in blue. And now I can see that my slope is going to be rise 1 and then run to the right 2. So here, beginning at the y-intercept, I'm going to rise 1 and then run to the right 2 here. So we land right here at this point. Now, here it's important to note that the domain is from -infinity to +4, and the 4 is basically this dotted line that I drew at the beginning. Now from the left, we're going to draw an arrow because this is going to -infinity. And then we're going to stop at this dotted line. So let's go up 1 and to the right 2. So I'm going to draw this open circle because right here we had a parentheses, and parentheses mean open circles when you're trying to graph them. So now we have our first piece of the graph, which should look something like that. And again, this is not to scale. This should be a straight line. I know it's a little crooked. So now here we have the open hole, and now let's see where the jump occurs here. That's going to be related to this second part of the graph. So in an attempt to graph this portion of the piecewise function, we first have to evaluate at 4. We're basically evaluating the function at this vertical line that I drew at the beginning. So here, let's attempt the substitution. F of 4 is going to equal 1/2 times 4 plus 1. So again, evaluating this function at 4. And now let's compute here. 1 times 4 is the same thing as 4. And we still have the denominator of 2. We have to add 1. And then you can do this by putting it in a calculator or using mental math. But 4 over 2 is 2. And then we have plus 1. So we get that f of 4 is equal to 3. And here's where we're going to get the jump, or that closed circle. So let's look at our line here. And actually, let's look at the y-axis and search for +3. So we're going to have 1, 2, 3 right there. So we get a closed circle right here. So let's go ahead and plot it in purple. Alright, and this is going to be the beginning of our second part of our piecewise function. So here the slope is 1 over 2, so I have to rise 1, run to the right 2, beginning at this jump. So we have rising 1, running to the right 2. So we pay attention to the domain once more, and we can see that we have an infinity here. So to the right, we should have an arrow. And that would be the completion of this piecewise function. And sorry, for some reason this portion got erased, but this should be the final product. Alright, let's graph this one now. So here we see that this time we have a potential jump occurring at +1. So let's look for +1, which is right here, and then let's draw that vertical line because there's going to be a potential jump here. So here's x equal to 1, and now let's graph this part. So let's begin by getting the y-intercept of +5. So the +5 is right here, and now the slope, or the slope, is going to be -2, and then since we don't have a denominator, the run is +1 by default. So we gotta go down 2 to the right 1. So we go down 2 to the right 1, and here's where we draw that open circle, because again there's going to be a jump occurring somewhere potentially. So that takes care of the first part. So now we have to take care of the second part. So here let's finish drawing this part of the graph. So we got to connect these points, and then on the left this is going to -infinity. So on the left of the graph we have to draw an arrow. Here what I would normally do is, in order to graph the second part, we would evaluate at 1 now. So let's write that down. Evaluate at +1. But then f of 1, there's no x here to replace it by a 1. So our answer is just going to be -2. And that -2 is where we will draw that closed circle. So let's look for -2. And -2 is right here, so the closed circle happens right there. So we plot that point there. And now we have to draw a horizontal line because this is a constant function. And we're going to draw it from 1 towards infinity. So it has to go to the right. And then it's just going to end with an arrow, because again we have infinity on the right. So let's try this one now. So we have the potential jump occurring at +3 now. So let's draw this vertical line indicating where we could have a jump. So at x equals 3. And now let's begin graphing this. So the y-intercept is at -2. So I see my y-axis right here, and finding -2, we're not going to plot it here in red. Let's get the slope of this line. So the slope here, it's x, but that's just 1, and then there's no denominator, so my run by default becomes 1. So 1 over 1. So now we go up 1 to the right 1, up 1 to the right 1, up 1, and then to the right 1 with an open circle, because we don't know where the jump is going to happen. Let's concentrate on the second part now, on this one. And actually I always forget to do this, but we have to connect the dots here. And now here we're lucky because our endpoint, our lower bound, is at +0, so we don't have to extend it any further. This line exists from 0 to +3. So let's evaluate the second part at 3. So we get that f of 3 is the same thing as 1/3 times x. Well, 1/3 times 3, because x is being replaced by 3 now. And that's just 1. So we have to close at +1. So we have 1, and look, the closeness actually happens at this open spot, so we have to shade it in now. And now we can finish graphing the second part, because the slope here is going to be up 1 to the right 3. So we go up 1 to the right 3, 1, 2, 3 right there. And this time we have to go all the way to positive 9. So 5, 6, 7, 8, 9. So let's draw another boundary here, because this is where this graph is supposed to end. And it's going to end with an open circle. So let's go up 1 to the right 3, which is right here. And that would be the graph of this function.